Today we're going to talk about open spaces. Open spaces are areas of land, open air, that are not built upon. They can be gray or green spaces. Gray spaces refer to those that are not covered with vegetation, such as squares, and green spaces are those that are covered with vegetation, such as parks.
Why is it important to properly map these open spaces?
Open spaces are important for livelihood, and the absence of open spaces can have various negative impacts. For example, missing spaces for economic development, informal streets. They can also be associated to an increase of urban temperature, which means that they have less environmental quality, and people without sufficient open spaces, they can have also an increased risk of obesity. And open spaces are also important for evacuation in case of disasters. For these reasons, the SDG 11 focus on the provision of open spaces for all, and this specifically make cities and urban settlements safe, resilient, and sustainable.
And how are these open spaces currently mapped?
We focus on a specific indicator that it was indicator 11.7. This indicator relates the average share of open spaces in a city and compare the total built-up area with the areas that are open. As I mentioned before, gray spaces such as squares, streets, and green spaces such as parks. This is not presently available in the SDG database, and this is because it's complex and has sort of financial cost associated.
And what makes it complex?
Because the data is not available or reliable. For example, imagine to map a full city and describe and discover all the spaces that are open to the people and classify green and gray spaces.
And what did you develop in your research in terms of the open spaces?
Yes, in my research, we developed a workflow that can map from the space using satellite images to quantify this share, the amount of built-up area in relation with the spaces that are open, green and gray spaces. And we utilize free for research images from the Planet platform and open data from OpenStreetMap, also census data, official census data that we had access to, and a free for research cloud computational platform that is Google Earth Engine. So our workflow proved that it's possible to operationalize the SDG indicator to map and monitor this built-up open area.
And can you show us results of how you've done this?
I developed, as I mentioned, the workflow, and I did for a multi-temporal study. And this study utilized something that is called an ensemble classification approach. This classification approach, which does is that combines several classifiers, and with a mechanism, they produce a more accurate result. And we did a multi-temporal study, so we had data from 2010, 2016, and 2018. So we applied this approach to each data sets per year, and we obtained image classified per year. So we could quantify this indicator, and we could produce a report that shows how the built-up indicate the trend of the built-up area. Our results show for a specific city. We focus on a specific city that was Kampala, and we show that from 2010 up to 2018, there was an increased area in the built-up. in detriment of the vegetation. And this is also shown in the map, because in the red we can see how the progression of field top in the city, in the area that we study. So we also see the decrease in vegetation.
What does your research improve in the open spaces?
Well, first we address two main bottlenecks. One is the access to data. So we prove that we can operationalize this indicator for a full city. It was a huge area. So using images from planets that are free for research, and also using data from OpenStreetMap and a cloud computational platform that is also free for research, we address main bottlenecks that prevent cities to address this problem. And in this case, it was shown how this can be done. Actually, I presented this work in a conference, and yeah, there was more follow-up. And this is in one hand. And another hand, we also show how cities, and in this particular case study, how there was the city dynamic, and how people were losing vegetation. Yeah, we need more built-up areas, but this has to be more in a sustainable manner. So we prove that it's possible to map from the space this indicator and to address a pressing issue in cities.
And what does the future look like? So what are the next steps within this area?
Well, we have every day more and more available data. So there is data from Sentinel, for example, and more data from Planet, different platforms that provide data to map and to address these kind of problems. What we need is more capacities to really kind of implement an infrastructure or a system that can monitor not only one particular cities. This research in particular is reproducible, can be done, more people can follow the workflow and can produce similar results because it was implemented for a specific case, but the approach is generic. So this can be done. I think that we should embrace the opportunities that we have with more data, with more cloud computation that is available more and more, and also use two paradigms, because I combine in this research two paradigms. Open data not only from the formal scientific sector, that is, for example, the satellite images coming from Earth observation, but also the citizen part, the volunteer data that comes from OpenStreetMap. And I think that this is also an important aspect from the future that could be more common in the future, combine these two approaches to do more science. And I will be happy if somebody can reach me out to collaborate in this sense.
Yeah, thank you for this interview, Rosa.
My pleasure.
Do you want to be a GeoHero as well? Then take the first step and click the subscribe button and then the bell button to always be the first to know when one of our GeoHeroes posts a new video.